Hello everybody, welcome to this walking talking guide through a GCSE exam paper. As you can see, we're going to do a foundation calculated paper today, so do make sure you've got yourself a calculator to hand. A pencil, a ruler and a compass will be quite useful too. And basically I'm just going to take you through a paper. I'll offer a few, obviously do the answers, offer a few kind of hints and tips as we go through. Feel free to pause this video, rewind it if you need to go over some stuff. Make sure you got a copy of the paper to go through with me. So let's get started. Right, number one. In a survey, people are asked to choose their favourite types of pizza. The pictogram shows some of the results. 8 people chose margherita. Complete the key. So, nice and easy to begin with. Complete the key. So, 2 whole pizzas worth 8. So, straight away, we know it's 4 people. Okay? How many people chose pepperoni? So, therefore, we know that's 14. And then there are 36 people in the survey. All of these people chose a pizza. Complete the pictogram for veggie. So what we've got to do for ourselves, we knew that there were 8 doing margherita. We know there were 14 in pepperoni. We get the other 2, which is 6 and 4. And if we add those up, we're going to get ourselves 32, which leaves us 4 left. And therefore, I'm simply going to draw one of those in the veggie slot. Okay? Now, I think it's important to point out that last part was a 3 marker, and we want to make sure that we're getting every mark we possibly can at the start of this paper. Okay? Right. A little bit of bid maths first. 2 plus 4 is 6, and 5 6 is 30. 3/8 is a decimal. 1/8 is 0.125. If you didn't know that, again, because we're on a calculator paper, actually, this is probably the non-calculator method. We just do 3 lots of those. All you simply have to do would be, and let's just check the calculator shows up okay. 3, yeah, that's not bad. Divided by 8, 0.375. Okay, and we pop that here. Right, 42% is a fraction. That's nice and easy. Percent means out of 100. They're both even numbers. Divide by 2. 21 out of 50. Job done. Tia thinks of a number. She finds the square root and subtracts 4, and her answer is 1. What number is she thinking of? So she's got a number. She square roots it. She takes 4, and her answer is 1. So we'll do what we've done in the classroom many times together. We'll go back the other way. What's the opposite of taking 4? Adding 4. What's the opposite of rooting? Squaring. I'll represent that by a little power of 2. And therefore, 1 plus 4 is 5 squared. And the answer must be 25. Okay? A fair spinner has 5 sides. Each side is labelled A or B. The diagram shows the probability scale. Blah, 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 blah. Circle the word that best describes this probability. That is unlikely. Bear in mind that halfway 50-50 is 50-50. It's evens. The other side of that will be likely. 1 will be certain. 0 will be impossible. And therefore it's unlikely. Here is a spinner with 2 sides labelled. Calculate the other sides with A or B to give the correct probability. So let's just go back up. This is a probability of 0.4. 0.4 is the same as 4/10. 4/10 is the same as 2/5. And oh look, my spinner is a pentagon. It has 5 sections, and therefore I need to make sure that 2 of my sections are labelled A, and the others are labelled B. Done. Okay? Quite easy to miss a question like 5A. You know, you've got to be reading the questions carefully. Sometimes it is quite easy to skip over and miss. Starting with the order, following in order of size, start with the smallest. Now you'll notice they all begin 0.4 something, so we've got to look at the second decimal place. So we've got a 0.40, we've got a 0.41, so we can start with those. 0.403. 0.41. And then the next two are 43 something. So we go to the next decimal place, and that's 437. And then finally 438. Job done. Now be very, very careful with that. Do not read these numbers as 0.403, 0.41, 0.4374. If you do that, you will get it wrong. They are individual decimal places. Incredibly important. Next, 7a. Show the inequality x is greater than 3 on the number line. Done. Okay, that's the difference between an open circle being greater than, and for your own benefit, a closed circle is either less than or equal to, or greater than or equal to. So we do need to be careful. Okay, the simplification, 4a plus 7a, and then I've got, and I like to either colour code these or put them in different shapes. A plus 3c and a minus 5c. So that answer is going to be 11a, 4a plus 7a, and then I've got a positive 3c, take away 5c, which is minus 2c. Okay? Finally, 2x divided by 3 is 4. So again, we just do the opposite. What's the opposite of dividing by 3? Times in by 3. 2x equals 12. What's the opposite of times in by 2? Divided by 2. X is equal to 6. Job done. Let's bring that down a little bit. This table shows the ticket price for each person to visit a zoo in winter. A family of 2 adults, 1 child aged 8 and 1 child aged 1 visit the zoo in the winter. What is the total cost of the ticket? So real simple. We've got 2 adults, 2 times 18. 1 aged child aged 8, so that's 1 lot of 14. The 1-year-old is free. 2 18s are 36. Add the 14, 50 quid. In the summer, the zoo increases the prices. An adult ticket increases by 20%, a child by 15%. So again, we've got a calculator, so we're going to do 18 multiplied by 1.2. Where have I got the 1.2 from? Well, if it's increased by 20%, that's 100 plus 20, that's 120%, which is a decimal is 1.2. Okay, and I'll do the same with the child ticket. 100 plus 15 equals 115%, which is 1.15. So that's going to be 14 times 1.15. We can do both of these calculations. So 18, let's get that on the screen. 18 times 1.2, 21.6. 14 times 1.15, £16.10. Let's put the zeros in. And then let's go back to where we were. 2 adults, so we're going to times the top one by 2. So £21.60 times by 2 plus £16.10 equals £59.30. Now read the question carefully. How much more does it cost? £9.30. Got to read the question carefully. Otherwise, again, we wouldn't be getting that last mark. We'd be getting 3 out of 4. Denisha is going to visit 2 of these places, the London Eye, Buckingham Palace, Tower of London, the British Museum. I'd recommend a little trip to the British Museum. Excellent stuff. And also the Tower of London, to be fair. Very interesting. So let's list them logically. They've already done the London Eye and Buckingham Palace. So I will do the London Eye and the Tower of London. And I will do the London Eye and the British Museum. So they're all the London Eye combinations. I will then go Buckingham Palace, Tower of London, Buckingham Palace, the British Museum. Now we've got to be careful. I wouldn't now write the British Museum and the London Eye because that's already been done. Okay? So they're the ones. And then the only one I haven't had is the Tower of London and the British Museum. Okay? Now, it does say you may not need all the rows. So again, read the question carefully. Don't be expecting to fill that out. What fraction of the combinations include the London Eye? So the top 3, and there's 6 altogether. And the examiner, in this case, will let you have 3 out of 6. and we'll also let you have a half because it doesn't say anything about giving the simplified answer. Here are two identical tiles. Sketch two quadrilaterals that can be made. Joining the tiles, write down the mathematical name of each quadrilateral. So, first one's nice and easy. If I take that triangle and spin it round and pop it in there, I've done that nice and faint. You can see that quadrilateral number one is a rectangle. Okay, nice and easy. All right, next one. If I turn this triangle upside down, and I can actually pop it down there and down there. I'll make that one a little bit harder for you. You can see you make a parallelogram. Okay. Now, there is one more, and it does say two, but just in case, there is one more. If I join the diagonal to the diagonal, okay, what you get, and I'll put the right angle in so you can see what I'm doing, is you get a kite. Okay? So there is a third one there, should you get it. Okay? The two triangles can be joined, the two tiles can be joined to make two different triangles, work out the interior angle of each of the triangles. Okay? So I'll use the diagram on the left to help us. So I could come down there like that, and you can see that 60, 60, 60 is an equilateral, so I'll be writing 60, 60, 60. And then the other one is I could come, and I'm just going to run out of space here, but you'll probably get the idea. Obviously that should be a little bit longer, but you get the idea. So that would be 60, that would be 30, so the top angle is now 120, so it's 30, 120, and 30. Let's just show you that at the bottom. Okay. Let's get that in line. Gill uses the formula H equals 2FG. Find the value of H when F is 1 and G is 3. Now this is just testing your algebra knowledge, that you know that that is 2 times 1 times 3. Done. Easy. Find the value of G when H is 18 and F is 6. So let's pop that in. H is 18, which is equal to 2 times F times G. 18 is equal to 12 lots of G. And we've done this so many times. What's the opposite of times in by 12? Dividing by 12. And 18 divided by 12 is 1.5. Okay? Fit in each missing number. So they're telling me that 0.36 times 20 must equal something times 10. So if I've halved the second timesing number, I'm simply going to have to double the first timesing number. 0.72. Now, of course, this is a calculator paper, so you could literally do 0.36 times 20, which is 7.2, and then, we could then just divide that by 10 to work it through. Okay? The second one, 14 divided by 50 is something divided by 100. Now, division works ever so slightly differently in the fact that if we double the second number, we're going to have to double the first number. So 28 divided by 100. And again, let's just prove that. So 14 divided by 50 is 0.28. And therefore, something divided by 100, it's got to be 28 divided by 100 gives you 0.28. 2 to the power of 4, again, you probably don't need a calculator. 2 times 2 times 2 times 2 is 16. Find the value of n. So 100 equals 4 times 5 to the power of something. So first of all, divide by 4. 25 equals 5 to the power of something. And again, probably don't need a calculator for that because it's squared. 5 squared is 25. 30 people chose their favourite sport. Matt wants to show their choices in the pie chart. 4 of the people choose tennis. Work out the angle of the sector for tennis. So all we're going to do is 4 people chose tennis out of 30. So that's the fraction. A pie chart is out of 360. So 4 divided by 330 times 360, 48 degrees. Easy. Okay. Using a ruler and compasses only, construct a perpendicular bisector. Love a perpendicular bisector. Now I'm just going to turn the test paper on its side to give me a horizontal line to make my life easier. I've got my compass. I've got my pencil. So I'm just going to pop it in. Put my compass at one end. Open it about 3/4 of the way across. Draw myself half a circle. Well, put a bit more than half a circle. Like that. Don't touch it. Put it on F. Do exactly the same. And then just take that out of the compass. Grab a ruler. Straight through. Done. Perpendicular bisector done. Okay. And again, I would suggest to you guys is if that's a perpendicular bisector, do you know how to do an angle bisector? Okay. In a dance competition, 2 judges score out of 30. The scattergraph scores the first 10. Now, the amount of times I've seen pupils do questions like these, and they do 2 things. Number 1, they just ignore the box and don't bother putting any more points on, and then jump in with a line of best fit. Or what they do is they will plot just the top 2 numbers, 21 and 7. No, we've got to be very careful. The bottom is judge A. The other axis, the y-axis, is judge B. So this is one coordinate, this is the other coordinate. So we've got to be very careful. So I'm going to plot, and you've got to be exact. You can clearly see that's 21. So I'm going to go 21 to 18, 15, 16, 17, 18 is in there, and then 7 and 8, which is in there. Easy. Dancers who are awarded a score of 20 by both judges, let's just move that down so you can, there we go, receive a medal. From the 12 dancers, express a ratio of medal winners to non-medal winners in its simplest form. So essentially, we are looking for people who have scored 20 or more in both. So that is anybody in that section there. Anybody in this section here must have had 20 more in that way and 20 more in that way. So that's 3. So if there's 3 medal winners, in fact, we can probably take that off now because we know there's 12. 3 medal winners, 12 altogether. So 3 to 9, which is 1 to 3. Okay, be very careful because it says medal winners to non-medal winners. So we've got it that way as we go through. Here's a pie chart. Why it makes it look like the front wedge looks bigger than it should because it's a 3-dimensional image. Okay, so front wedge looks bigger. Okay, you could say it's on an angle, it's 3D, but it's basically that front wedge doesn't look like a representative shape, and it should do. Okay. Classic mean of group data. So hopefully you guys know the mean of group data now. Sometimes they give you 2 columns, sometimes they give you 1 column, sometimes they will just give you that piece of information. The first column here is for the midpoint, so that's 10, 30. Now be careful, 45, 55, and 70, because look at the gaps as we go through. So we've got to be very careful. Then we're going to do a multiplication. 5 10s are 50, 8 30s are 240, 37 times 45, 1665, 47 times 55, 2585, and 3 of those is 210. Add them all up, 50 plus 240 plus 1665 plus 2585 plus 210 equals 4750 divided by how many there are. Now be careful, there are not 5. Okay, divided by how many is the total of that column. So 13, 50, 100, Is it miles per hour? Yes. 47.5 miles per hour, 47.5 miles per hour down there. Okay, so midpoint, times them, add them all up, divide by how many there are, and then be super, super careful with making sure it's out of 100. And the last part's very stereotypical. Explain why it's not possible to calculate the exact value, because we're not given exact speeds. Okay, all I know, for example, in that first column, is that there are 5 vehicles that went between 0 and 20. I do not know whether they were 3 miles, 4, 5, 6, 12, 17, 18, 19. All I know is that those 5 vehicles were somewhere between 0 and 20. So we can't get the exact value, which is why it's called an estimate. The diagram shows a square, regular hexagon and part of another regular polygon meeting at a point. Show the size of one interior angle of a regular hexagon is 120. There's a couple of ways you can do this. So we can say to ourselves, a 4-sided shape adds to 360. A 5-sided shape adds to 540. A 6-sided shape adds to 720. And if it's a regular hexagon, 720 divided by 6 is 120. Okay? That would work. Or you could say to yourself, we could work with the exterior angles. So 360 divided by 6 gives you 60. So the exterior angle is 60. And then we know the exterior plus the interior is equal to 180. And therefore, we can just do 180 minus 60 equals 120. Okay? Find the number of sides of the other irregular polygon. So we've got 120, we've got 90, so that's 210. So I've got 150 left. Okay? Now, again, what I'd be doing there is I've got 150, and that's the interior angle. Then I know the exterior angle must be 30, because that equals 180, and therefore 360 divided by 30 gives me a 12-sided shape. Okay, if you need more information on interior and exterior angles, again, Corbett Maths would be the place to go, and would fill you in a little bit more on the work of interior and exterior angles. This graph shows part of a straight line, right down the y-intercept. Here is y, here's the intercept. Done. That's it. This graph shows a part of another straight line. Find the gradient. Now, the gradient's always interesting. People are always like, Lamb, where do I put? I know I need a little triangle, but I'm never sure where to put the triangle. I would always go from the intercept, and I would always be using whole triangles. So I wouldn't stop here, because that's not a whole square. So I'd be going along here and up here for a triangle like that. Remember, the gradient is m, it's the change in y over the change in x, and that is obviously equal to a half, 1 divided by 2. The line is continued to the right, and will it pass through that point? So basically, we want, and lots of you remember the general form, y equals mx plus c, that's the general form for the line. So I can get that for my line. It's y equals a half x plus, and it's clearly 1. And then, again, if you're in one of my groups, we've done this a couple of times together. This is a coordinate. So this is the x coordinate. This is the y coordinate. Okay, so all you do is we put the numbers in, and if it works, it's on the line, and if it doesn't work, it's not on the line. So 102 equals a half of 200 plus 1 doesn't work, not on the line. Okay? And again, if you need some more of a reminder of y equals mx plus c, again, you'll find that in Corbett Maths videos. A bee flies from its hive to a flower at constant speed, 7.5 meters per second for 10 seconds. So we're talking speed is distance divided by time. Classic formulas. The bee then takes 15 seconds to fly back to the hive. Assume the bee always flies in a straight line and ignore the time spent at the flower. Work out the overall average speed of the bee. Okay, so essentially we want to know how far it is to the from the hive to the flower. So if he travels 7.5 meters every second and does that for 10 seconds, we know it's 75. We know if he's going there and back, he's going to cover a distance of 150. And we also know it's 10 seconds there, 15 seconds back. So it's going to take us 25, and 150 divided by 25 seconds is 6 meters per second. Okay. If the bee is not assumed to fly in a straight line, how might your answer be affected? If it's not going in a straight line, then the distance will be further, and therefore, again, the meters per second will be different. Okay, so the bee may fly further. Question 21. Now we're lucky. It says the word trigonometry for ourselves. Okay. Sometimes questions do not say use trig. Okay. So they've signposted it for us. They've made it very obvious. So we look at the sides that are involved. This is opposite. This is the hypotenuse. And then you guys would have walked into the exam, and one of the first things that you would have written on your page, probably at the front, is SOHCAHTOA. We've got the opposite. We've got the hypotenuse. So that's sine 20 equals x over 10.2. What happens when the unknown's on the top and the number's on the bottom? That's where everybody, you multiply 10.2 times sine 20. Let's do that now. Make sure your calculator's in degree mode. 10.2 times sine 20. And we've got 3. Now I'm going to write quite a few decimal places here because it doesn't specify. So I could write in my answer box 3.5 and it would be okay. And I could write 3.49 and it would be okay. So do be careful there on your rounding. Okay, nearly there. Just a couple more. A newborn baby has an approximate mass of 3.5 kilos. A human cell has an approximate mass of 2.7 times 10 to the 11 grams. Use these values to estimate the number of human cells in a newborn baby. So my first job, I want the newborn baby in grams, so everything's in the same unit. And if for every gram that there's that many cells, we're just going to do 3,500 divided by 2.7 times 10 to the power of 11. Okay, let's get that on the calc. 3,500 divided by 2.7. Here's let's just move that up. There's my power. There you go. Times 10 to the power of negative 11. Oh, I just put a minus in. Divided by 2.7 times 10 to the power of minus 11. There we go. And again, 2 sig fig. 1.3 times 10 to the 14. Okay, real simple, real straightforward. Nearly there. This map shows part of a village. Neil knows that Packer Street is 180 metres long. He measures the map. Blah, blah, blah. If 3.5 centimetres, High Street is 11.2. Therefore, I calculate the High Street is 576. Show that his calculation is correct. So basically, this is finding the scale of the map. So there's 180 metres divided by 3.5. Times 11.2 equals 576. Boom. Okay. Straightforward. Jodie measures the same map, so I'll leave the map in the picture. She says, I think Packer Street is longer than Neil's measurement of 3.5, therefore High Street must be longer than 576 in real life. Is her reasoning correct? Now, the best way to do this is just put an example in. All right, so let's say he thinks she measured it longer. Let's say she measured it 4 centimetres. So if Jodie now does 180 divided by 4, let's say, okay, and times that by 11.2, 180 divided by 4 times 11.2, oh, that equals 504, which is less than 576, not longer. And that's how I would decide whether she's right. And I would definitely be writing, no, she is not correct. Okay? On another map, Packer Street is 2.4 centimetres long. I express the scale of the map in the form of 1 to n. So let's just check. Packer Street, remember, is 180. So 180 metres. So we've got to be careful. So 180 metres is that many centimetres. So it's 2.4 centimetres to 18,000 centimetres. And then we're just going to divide by 2.4. 18,000 divided by 2.4 is 1 to 7,500. Okay. Nice and easy. Direct proportion, A. Inverse proportion, C. Nice little memorization question. You guys did proportionality in November time. So again, I'm hoping that's relatively familiar. And the final one, which looks quite complicated, but for the last question on the paper is relatively friendly. The length of each side of a square is 3x. The length of each shaded corner is x. So you can see that, and you can see the 3x. Use the information to show that the shaded area to the unshaded area fraction is 2 over 7. Okay, so what we're going to do is the whole square is going to be 3x, because it's a square. So 3x times 3x, which is 9x squared. Now, if you look very carefully, if I was to put this into here, I have a square of size x squared, and I would have 2 of them. So I can tell you the shaded area is 2x squared. Thus, if the whole thing is 9x squared and the shaded is 2x squared, the unshaded must be 7x squared, and cancel the x squareds, and I get 2 over 7. Done. That's the paper. That's 100 marks. Live the dream. Thanks for your time, and I'll see you again soon. Cheerio.